I'm Michael Gibbs, and in this video I will be showing you how to create a Lewis dot structure for a covalent molecule. And that covalent molecule is, so what I'm drawing right there is C for carbon, and it's a little hard to tell because it got cut off. Now the first step to creating the structure is by determining how many valence electrons are in carbon and how many valence electrons are in hydrogen. So if we check our periodic table, we will see that carbon has 4 valence electrons. So 4. And we'll see that hydrogen has 1 valence electron. Then we take that number and multiply it to the respective pairs. Not pairs, but the respective subscripts. So that becomes a 12, and that becomes an 8. You add those two together to get 20. The next step to creating the Lewis dot structure is by taking that number, 20, and dividing it by 2, and we get 10. Once we have that number, we see how many unshared pairs there are in this instance. Now for this case, there are no unshared pairs, so we subtract 0. If there were, say, 2 unshared pairs, we would subtract 2. But there aren't, so we just subtract 0. And this, of course, comes out to 10. Now, 10. That's how many bonds we need to create when we're forming our Lewis dot structure. So the next part of the video is going to be the actual structure itself, and I'll show you how to form that. So the next part of the video was accidentally filmed sideways, and I accidentally did it twice. But I kept it the same because I thought it added character, and the video's content is still relatively unchanged, and if you need to just flip it sideways, otherwise it works out alright, and I hope you like my quirky but flawed video. Thank you. Okay, after we've done our calculations, we begin creating the actual Lewis dot structure itself. Now to do this, we have to figure out which element has the most empty spaces in it. So we go over here and write carbon, and we write hydrogen right here. Now here's carbon structure, and here's hydrogen's. Now carbon has 4 empty spaces, one here, one here, one here, and one here. 4 empty spaces. Now we check hydrogen. Hydrogen only has 1 empty space. It only has 1 empty space because it does not follow the rule of octet. So this has more empty spaces, which means that we put this at the center of our Lewis dot structure. And because there are 3 of them, we have to put all 3. There are all 3. Now, I'm going to change color for the next part, but now we create our bonds. And remember, we have to have 10 bonds. That's what we calculated before. So we put 1 here. We create it like so. And each of these lines represents 2 valence electrons. So already, we've completed the rule of octet for each carbon. If each of these equals to 2, 4, 6, 8. For each of them, we've already completed the rule of octet. Now all that's left to do is add our hydrogen. 1 there, 1 there, 1 there, 1 there. Hydrogen for everyone. Perfect. And since we had 8 hydrogen, let's count them up. Good, 8 hydrogen. And since they only have 2 valence electrons, and each of the lines represents 2 valence electrons, those are all completed. And if we count 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 6, plus 4, it's 10. 10 bonds, which completely satisfies our Lewis dot structure, making it perfect. One good-looking Lewis dot structure, if I do say so myself, and I do. Thank you for watching.